All right, last couple problems on the review. This one says, given the functions f of x equals x squared and g of x equals 2 to the x, find the total area bounded between the two curves. Normally, total area means throw an absolute value around something. But actually, this is just because x squared and 2 to the x, they intersect in two different places. So let's take a look. It's kind of hard to see on the graphs too, but let's see. 2 to the x. I'm going to set the window like 0 to 15. I don't remember where they intersect the second part. I think that's enough. And then we'll like zoom fit. Oh, that was not good. So hold on. Let me do 0 to like 5. Okay, this is a little bit better to see. So the let's see. The red is the 2 to the x. So see how it's 2 to the x on top and then x squared? And that's going from 0 to 2, right? Because 2 squared is 4 and 2 to the second is 4. So let's graph this. So yeah, so 2 to the x is on top. Oops, is on top at first. Gosh. Because you are at like 2, 1 or 0, 1, and then this graph kind of goes up like this. And x squared is on the bottom at first because it starts at 0. When we get to 2, we hit 4. This is totally off scale, by the way. I'm sorry. So anyway, so we hit 4 like that. And then what's going to happen for the other part? Well, the 2 to the x starts growing faster here. So then the x squared is, or I'm sorry, the x squared is on top here, and the 2 to the x is on the bottom. So where does that happen? I believe it's 4, right? 2 to the 4th is 16. 4 squared is 16. You could verify that on the calculator, but that's got to be right. So again, my scale is way off, whatever. But the idea is that you have, for the first part, you have 2 to the x on top, x squared on the bottom. And then you switch so that it's 2 to the x on the bottom, x squared is on top. That means that we need two integrals. We're just finding area. So the first area is the integral from 0 to 2. And the integrand would be 2 to the x minus x squared dx. And then you're adding to that this next area, which spans from 2 to 4. And for this one, x squared is on top, 2 to the x is on the bottom. And then we put this in our calculator and see how it comes out. So 2 to the x minus x squared. And then add to that the integral from 2 to 4. And this time it's x squared minus 2 to the x. So 3.016 is my approximate answer. All right, for this next one, given the region bounded between y equals 1 minus x over 2 and negative 1 plus x over 2 and x equals 0, find the volume of a solid where cross sections perpendicular to the x-axis are squares. So let's graph this thing. Now let's see, if we plug in 0 to the first one, we're at 1, and it's got a slope of negative 1/2, so it does something like this. The other one would start at negative 1, and it's got a slope of positive 1/2, so you're getting this little triangle thing happening. And let's see, this spot where they intersect would be 2, right? If I plug in 2, I get 1 minus 1, and if I plug in 2, I get negative 1 plus 1. So yeah, so that's 2 where they intersect. Cross sections are perpendicular to the x-axis. So here's an example of one of the squares. That's the side of the square, and then it stands up there. So area of a square in general is side squared, and the side is going to be top minus bottom. So our volume does not involve pi for these. It's just the integral from 0 to 2 of what's on top and what's on the bottom. The line with the negative slope is on top, 1 minus x over 2, minus the line with the positive slope, negative 1 plus x over 2, dx. Now I might clean this up just so I have less to type in on my calculator. So let's see. So it's really 1 plus 1 is 2. And then negative 1 half x minus 1 half x is negative 1x minus x. This one's 2. So that's our total volume. Oh, no, wait. Squared. I forgot to square it. Do that again. I think I've got to put separate parentheses around here to be able to insert the squared. There we go. Okay. 2.667, or we could make that a fraction. 8/3. Get that out of there. So that's equal to 8/3. The region bounded, this is our last one. The region bounded by the y-axis, y equals e to the x and y equals k, where k is bigger than 1, is rotated about the x-axis to form a solid with a volume pi. Find k. So let's see. E to the x is a graph that looks like this. That's e to the x. We're bounded between that and the y-axis, and some line y equals k. And here's 1, so y equals k is bigger than 1, so it's above that mark. We're rotating about the x-axis. So if you do that, you're going to get a washer method shape, right? There will be some empty space. So the outer radius spans from k to the x-axis, which is our axis of rotation. So capital R is k minus 0. Lowercase r connects the curve to the x-axis, so that's e to the x minus 0. And what would this value be right here? We need our cutoff for our x value. So remember, k is the y value, so that's like k equals e to the x. How do we solve for x? We natural log both sides. So that natural log of e to the x is just x. So our integral should go from 0 to the natural log of k. And then it's of r squared, so I'm going to write k squared, minus lowercase r squared. Now you can write e to the x squared or make that e to the 2x. I'm making it e to the 2x because we're trying to solve for k, so we need to have stuff simplified. And that's going to equal the volume, which was pi. And oops, pi is what I'm supposed to have in front of this too. Pi times capital R squared minus lowercase r squared equals pi. So that means I can divide by pi right away. So actually, this integral is just equal to 1. And then I need to integrate here. So remember, k squared is a constant. So when you integrate a constant, you get that constant times the variable, which is x. And then what about this minus integral of e to the 2x? So remember, there's a little bit of u sub happening here. U is 2x. Du dx is 2. That means du divided by 2 is dx. So that means that the integral is going to get a 1/2 to satisfy the du piece. So that means that this is minus 1/2 e to the 2x. And we're evaluating it from 0 to natural log of k. And that's going to equal 1. All right, so plug stuff in. So k squared times natural log of k minus 1/2 times e to the 2 natural log k. We'll simplify that in a minute. Minus parentheses, plug in 0 there, and then minus 1/2 e to the 0, which is just 1. Again, equals 1. So k squared times natural log, oops, this is not x, this is natural log k. Can't do anything with that. But we can simplify this. Now be careful though, you can't cancel the e and the natural log until you make that k an exponent, or that 2 an exponent. So it's e to the natural log of k squared, which leaves us with minus 1/2 k squared. Minus 0 plus 1/2 times 1, so plus 1/2 equals 1. And how am I going to solve this? Remember, you have a calculator. We would not solve this algebraically. K is our unknown right now, so I'm going to type in x squared, natural log of x, minus 0.5 x squared plus 0.5. When is that equal to 1? I'm going to zoom 6, that intersection point right there. So about 1.895 is what our K value is. All right, so that was kind of a challenging problem, mostly just because of some of the pre-calc stuff we had to remember. But yeah, the general concept was set up the area, set it equal to pi, and start solving. Okay, that finishes the review. Come into office hours if you have any extra questions.